You know, it's funny. We go through life always thinking about what's next, right?
Yeah.
Like deadlines, vacations, that sort of thing.
Uh-huh.
But what about the ultimate what's next?
Yeah.
The end of everything. I bet you thought about that at least once, like while looking up at the stars.
Oh, absolutely. It's a question that has fascinated people probably since, well, forever, since we first looked up and wondered, like, what's our place in all of this?
Totally. And in this deep dive, we are going to tackle some of the big theories about how the universe might end.
Okay.
We'll be looking at the research paper you sent
All
over,
right.
unpacking all the mind-blowing possibilities, but in a way that, you don't need to be like an astrophysics whiz to get.
Yeah. I think what's so cool about these theories is they're based in what we know about physics, about the universe,
Mm.
but each one takes us on like a totally different trip to the end.
All right, so
Yeah.
to really wrap our heads around these end of the universe ideas,
Hmm.
we kind of need to set the scene first. The paper you sent, it starts off talking about the expanding universe. Can you give us a quick rundown on that?
Okay. Imagine a balloon with dots on it,
Okay.
and each dot is a galaxy. And as you blow up the balloon, those dots move further and further apart. And
Right.
that's essentially what's happening to our universe. It's constantly expanding. It's pushing the
Yeah.
galaxies away from each other.
Okay, so the classic expanding balloon, I got it. But here's what I don't get. If if everything's moving apart, doesn't that mean the universe is just going to be this big, cold, empty space?
That is one possibility. And
Right.
that's the idea behind what we call the big freeze,
Okay.
sometimes called the heat death of the universe.
The big freeze. All right, so walk me through that one. What would that look like? Like, would I still be able to get a decent cup of coffee at the end of the universe?
I doubt it. In the big freeze, the stars eventually they run out of fuel and they die, leaving behind these cold remnants, and even black holes, which gobble up everything. Even those eventually evaporate.
Wait, black holes evaporate?
Yeah.
I thought they were like, forever.
Yeah, it's a crazy concept, but Stephen Hawking, he proposed this idea that black holes emit a tiny bit of radiation
Yeah.
because of quantum effects near their event horizon. So they slowly lose mass and eventually, poof, disappear.
Oh, okay. So with no stars, no black holes, what are we left with? Just a lot of empty space.
Yeah, pretty much. And that emptiness gets colder and colder, like approaching absolute zero, where there's almost no energy left to do anything. It's not a pretty picture, I know. Imagine the whole universe as this giant cosmic icebox.
Brew.
Well,
That's a pretty chilly thought.
yeah.
And what about time? Like if everything's frozen, does time even mean anything in the big freeze?
That's a good question. And it's one that, physicists, philosophers, they've debated this. Does time still flow in a universe where nothing's changing?
Yeah,
It
yeah.
really makes you think about, like, what even is time?
Right. Like, is it just a measure of change? And if there's no change, is there even time? Wow, this deep dive is already getting deep.
Oh, yeah.
All right, let's move on to something completely different from the big freeze, this idea of the big crunch.
Okay.
So instead of everything drifting apart, what if everything comes crashing back together?
Yeah. Imagine that balloon again, but now imagine letting the air out slowly. Those dots, the galaxies, start moving closer and closer.
Right. So instead of cold and empty, we have this super dense, super hot universe, like almost like rewinding the Big Bang.
Exactly. Galaxies collide, temperatures go way up, and all the matter gets squished back into this incredibly dense point. This singularity. It's like a cosmic implosion.
Okay. That's definitely a more dramatic exit than the big freeze.
Yeah.
But what happens after the singularity? Is that the end?
Now, here's where it gets really interesting. Some physicists think the Big Crunch might not be the end, but a new beginning.
Are you suggesting this singularity could be like another Big Bang?
Yeah.
Like a cosmic phoenix rising from the ashes?
That's the idea. Imagine a universe that's constantly cycling between expanding and contracting, this never-ending dance.
A universe with no beginning, no end. Just
Mhm.
an eternal cycle of big bangs and big crunches.
Right.
Wow.
Does that mean time is cyclical? What happens to our consciousness? You, me? I mean, wow.
That's a mind-blowing idea.
Yeah.
And it kind of messes with how we think about time, right?
Mhm.
It's a cyclical universe. Time may not have a beginning or an end.
Yeah, it's a loop.
Just a continuous loop.
That's fascinating, but it raises so many questions.
Yeah.
Like, if each cycle is a new beginning, does that mean everything that happened before is gone? Or does, like, some cosmic memory carry over?
Right.
Does it even make sense to talk about, like, before and after if it's cyclical?
Those are great questions.
Yeah.
And they get to the heart of, like, what would this cyclical model mean?
Yeah.
It makes us rethink time, existence, what reality even is.
I'm already a little overwhelmed. All these cosmic twists and turns. I I have a feeling we're just scratching the surface here. We are just getting started. We've only begun to peek into the possibilities for how it all ends. And it gets even wilder, believe me.
All right, my brain is already spinning from all these cosmic possibilities. The big freeze, the big crunch, a cyclical universe, it's a lot.
And we're just getting started. Remember the balloon analogy? Well, imagine if the universe's expansion wasn't just constant, but it was actually speeding up.
Wait, speeding up, so it's getting bigger faster and faster. Wouldn't that mean the universe is just going to spread out even more, become colder and emptier even faster? Isn't that just like a super fast big freeze?
It's similar, yeah, but there's a key difference. This accelerating expansion, it's driven by something we call dark energy,
Okay.
and it leads to a scenario we call the Big Rip.
The big rip. Okay, I'm listening. What's so different about the big rip?
Well, it's not just things moving apart. It's that space itself, the fabric of space, is stretching at an increasing rate. Think of the balloon again. But now, imagine the rubber of the balloon itself is expanding, not just the air inside.
So it's not just that the galaxies are moving apart, but the space between them is actually growing. Like the universe is getting bigger at a faster and faster rate.
Exactly. And if dark energy keeps getting stronger, which some theories say it might, it could eventually overpower everything else, gravity, everything. That would lead to the Big Rip, where not just galaxies, but stars, planets, even atoms themselves get ripped apart as space stretches uncontrollably.
Okay, now that is scary. It's not just the things in the universe getting destroyed. It's the universe itself being, like, shredded. Is
Yeah.
there any way to escape the big rip? Or are we all, like, doomed?
Well, there's no escaping the Big Rip. If it happens, it's the ultimate cosmic unraveling. Nothing would be left untouched.
Well, that's a cheery thought. Maybe the big freeze is a more merciful end after all. At least it's slow and peaceful.
Perhaps. Speaking of peaceful ends, remember we talked a little about entropy earlier?
Vaguely. Something about disorder and how messy my desk is.
Well, imagine that messiness on a universal scale. Entropy, it's like a measure of disorder. The second law of thermodynamics says that entropy always increases over time.
So you're saying the universe naturally tends towards, like, messiness? And this connects to the end of the universe somehow.
Exactly. The heat death idea, which is closely related to the big freeze, suggests that as the universe expands and entropy increases, all the energy eventually gets spread out evenly. Stars die out, black holes evaporate, and everything reaches this state of equilibrium. No usable energy left.
So instead of a bang or a rip, the universe just kind of fizzles out, turns into this cold soup of particles that's almost more depressing than the other scenarios.
It's definitely less visually spectacular, yeah. But in a way, it's the most fundamental. Heat death, it represents the ultimate victory of entropy, the inevitable consequence of that second law of thermodynamics.
Okay, so we've got the big freeze, the big crunch, the big rip, and now heat death. Are there any scenarios where the universe doesn't end in complete destruction, or just this boring sameness? I'm starting to lose hope here.
Well, there's one theory that offers a slightly more optimistic and I'd say mind-boggling perspective. Vacuum decay.
Vacuum decay. That sounds ominous. What is that?
To get vacuum decay, we gotta dive into quantum physics, the weird world of quantum physics. This theory suggests that the universe might be in what's called a false vacuum state. It's like a temporary stable configuration.
Yeah.
But there might be a true vacuum state that's even more stable, a lower energy state.
So our universe is like a ball stuck on a hilltop, and there's a deeper valley it could roll down into.
That's a good way to think about it. Now, in quantum physics, things can tunnel through energy barriers. It's like a ghost going through a wall.
Quantum physics, always so strange. So you're saying our universe, this false vacuum, could suddenly tunnel into this true vacuum.
Exactly. And here's where it gets really wild. If that happened, it would create a bubble of this true vacuum. And that bubble would expand at the speed of light, changing the laws of physics as it goes. Imagine a wave of change wiping across the universe, destroying everything in its path.
Okay, that's officially terrifying. And this could happen anytime. Like right now, there could be a true vacuum bubble headed towards us, and we wouldn't even know.
Well, the chances of vacuum decay happening are thought to be super low, but it is a reminder that the universe can be unpredictable. It's like a cosmic game of chance where even the rules of reality could change.
I don't like those odds. So
Yeah.
it's either complete destruction, boring sameness, or a sudden reality rewrite. Are there any scenarios that don't make me want to, like hide under my bed.
Well, remember we talked about the big crunch and the cyclical universe? There's a version of that called the quantum bounce.
Okay.
And this one takes a more hopeful view.
Quantum bounce. Okay, tell me more. Does this one involve trampolines?
Ah.
Because I could use a little cosmic bouncing right now.
No trampolines, but I like the analogy. The quantum bounce proposes that instead of a hard stop at the big crunch, the universe bounces back, starting a new big bang and a new cycle, like a cosmic heartbeat, expanding and contracting over and over again.
So it's not a full stop. It's more like a comma, a pause before the next chapter. I like that. But wouldn't the universe eventually run out of steam after so many cycles? Wouldn't it become kind of, I don't know, predictable?
That's a great question. And it's something physicists are still trying to figure out. Some theories suggest that each cycle might be a little bit different, introducing new things into the mix. So imagine a universe that's always changing, always exploring new possibilities.
That's much more appealing than a universe that just ends or fades away. Even if our universe collapses eventually, something new and amazing could come out of it.
Right. The quantum bounce offers this glimpse into a universe that's dynamic, creative, and constantly renewing itself.
Okay, that's a much more hopeful note to end on. But before we get too cozy with the idea of a cosmic bounce house, I have a feeling there are even more mind-bending possibilities out there, aren't there?
You know me too well. We've only just started to explore the strangeness of the cosmos. And trust me, the journey only gets wilder from here. Buckle up.
All right, so we've explored a whole bunch of endings, haven't we?
We have.
The big freeze, big crunch, the big rip, heat death, even jumping into a true vacuum. You said there's even more.
There is.
My brain is ready for more.
Oh, yeah, good. Because things are about to get really meta. So far, we've assumed our universe is, the universe.
Right.
But what if it's just one of many?
Wait, are we talking about, like, the multiverse? Isn't that more like science fiction?
It's definitely a popular idea in sci-fi, but the multiverse is a real idea in theoretical physics.
Okay.
Imagine, countless universes, each one a bubble in this vast cosmic foam. Some might be like ours, others totally different laws of physics even.
So if there's a multiverse, how does our universe end? Or is that even, like, the right question?
That's the thing. If the multiverse is real, our universe's fate is just one story in a library of stories.
Yeah.
Some might end with a big freeze, others a big crunch, something we can't even imagine.
So it's like a choose-your-own-adventure cosmically.
Yeah, kind of.
Each universe gets its own ending.
It's a fascinating idea, but it makes you wonder about how important our universe even is.
Right.
If there are infinite universes, does that mean everything that could happen does happen somewhere? Does that change how we think about choices, actions, our very existence?
Yeah. If there's a copy of me somewhere out there making different choices, does that make my choices less important? This is giving me an existential crisis.
It's a big thought, for sure. The multiverse really challenges how we think about being unique and having a purpose, but it also makes us think about all the possibilities out there. Reality might be much bigger than we can even grasp.
Okay. A lot to process.
Yeah.
But let's come back from the multiverse for a second. You mentioned something about the universe transforming, not ending. Tell me more about that.
Right. Some physicists believe that the universe might not end at all, but rather change into something completely new. Think of a caterpillar turning into a butterfly.
Okay.
It's the same being, but in a totally different form.
So instead of a grand finale, it's like a cosmic makeover. What would that even look like?
That's the big question. It could involve the laws of physics changing, new dimensions popping up, something we can't even understand right now. Imagine something so strange we wouldn't even recognize it as our universe anymore.
Wow. That's both kind of exciting and terrifying. Even if we figure out how the universe ends, the answer might be that it doesn't. It just becomes something else entirely.
Exactly. It shows us we're still just starting to understand the universe. Our theories, they might be as limited as, a goldfish trying to understand the entire ocean.
You know, this whole conversation has made me realize that maybe focusing on how the universe ends isn't the right approach. What if the real question is, why? Why does it all happen? What's the point?
Now you're getting into philosophy, maybe even spirituality.
Yeah.
Some people think the universe has a purpose, a plan. Others think it's all random, no meaning. The answer, who knows? It's probably beyond us right now.
Maybe that's the beauty of it all. We're these tiny beings trying to figure out this universe that's so much bigger than us. It's both humbling and amazing.
I agree. And maybe that sense of awe, that constant search for understanding, that's the real legacy we leave behind, no matter how it all ends.
You know what? I started this deep dive feeling kind of nervous about the end of everything. But thinking about all these possibilities, it's actually made me more curious than scared. Even if our lives are limited, it's pretty amazing to be part of something so much bigger.
That's a great way to look at it. The end of the universe, no matter how it happens, it's something we can't control. But our curiosity, our sense of wonder that we can control.
I like that. So to everyone listening, next time you look up at the night sky, don't just see the stars. See all the possibilities, the mysteries waiting to be discovered. It's a pretty incredible journey we're all on.
And who knows, maybe someone listening right now will be the one to figure it all out. Until then, keep exploring, keep asking questions, and keep that cosmic spark alive.
That's it for this deep dive. Until next time, keep looking up and keep those questions coming.